All right, another problem of equivalent systems and finding equivalent force couple system. A mechanic uses a crowfoot wrench to loosen a bolt at C. The mechanic holds the socket wrench handle at point A and B and applies forces at these points. And these are the forces that we are seeing. Knowing that these forces are equivalent to a force coupled system at C consisting of this force, I can add an arrow here, and this couple, determine the forces applied at A and B when A sub Z is 2 pounds. So we know AZ, we know the equivalent couple and equivalent force at point C. We got to find 1, 2, 3, 4, 5 other forces that are here. It's interesting. Our force point C equivalent force is only in I and K, so it doesn't have any Y. So it's kind of like I and K minus 8. So it's going that way, and positive K. So it's something like this. That's our C. It's in flat in XZ plane. And then our couple moment is only in I. So this is our moment, equivalent moment. So if you get rid of all of the A's and all of the B's, this will be your equivalent system. Great to know, but we go back to our main equations that we have. When we have a force coupled system, we have two main equations. So all equivalent force is summation of all forces, which in this case that resulted in minus 8I plus 4K units of pound. And our moment is summation of all existing couples moment plus summation of all R cross F's. In this problem, there isn't any existing couples moment anywhere, only have forces. Again, this is due to moving forces to point C. Anytime you move a force, you're going to create some moment if it's not on its line of action. And this position vector is from point C to anywhere on line of action of each of those forces, which in this case I would say this is a good position vector right there, and another one would be right here. Okay, and the result of this turned out to be 360 I pound inch. All right, so we'll start with what we know, and we'll see if we can do we can find the unknowns. I mean, we should be able to. All right, so FR, summation of all forces, has resulted in minus 8I plus 4K pounds. Let's write force A and force B in Cartesian form. So it's AXI, AYJ, AZ, we know it's 2K, BXI, BYJ, BZK, resulted in minus 8I, 4K pounds. So what I understand from here, these two, if I add, I should get 8. J, if I add these two together, I should get 0, because I don't see any J on the other side. And then if I do K and K, add these two together, I should get 4. I'm going to start with that because one of them is 2 plus BZ equals 4. So 2 plus BZ equals 4 pounds. So 2 pounds should have units next to them. Right off the bat, I can calculate BZ equals 4 pounds minus 2 pounds equals 2 pounds as well. Next, I'm going to write the J's, or you can just do any order. AY plus BY equals 0. I can't solve it, but I can get from it that AY and BY are same magnitude but different directions. And if you look at the figure, it shows them on this pointing up, pointing in same direction. That's okay. They're unknown. So the direction of it that's on this force are just, all of them are put in the positive direction. Doesn't mean it's actually in positive direction. They're unknown, so whoever drew this picture just put them in positive direction. But now we know that, well, that can't be. AY and BY should cancel each other out because there is no J in the final answer. So and that's okay. You don't have to go correct the picture. You're not doing anything wrong. Your answer is also correct. And then lastly, let's do the x's. This plus bx, I know that should be minus 8 pounds. I can't solve it, 2 unknowns, but these are good information. Good equations. One of them is solved, and we can now move on to the moment to try to figure this out. Okay, let's continue with the moment equation. I know that my MR, which is summation of all R cross F's, which in this case, I suggest just writing one force. A is AXI, AYJ plus 2 pounds K, and force B is BX, which one did we find? BZ. BXI, BYJ plus 2 pound K. Sorry, it looks like 21. It's 2 pounds. 2 pounds. Okay. So we only need 2 position vectors. One from point C to line of action of A, which if I pick point A, right there, RCA. And if I pick point B, I can do RCB, and I'm fine. And this should result in 360I. Okay. R cross F, position vector from C to A, it moves 8 inches in X direction, 0 in J, and this is 10, that is 2, so it's 8 inches. So 8 inches in that other direction. AX, AY, and 2 pounds. Next one, I, J, K, this is for B. Position vector to go to point B, we're moving 8 inches in I direction or X direction, and then moving 0 in J direction. And how much we are moving? We are moving 2 inches in against positive Z, so negative 2 inches in that direction. And then BX, BY, and 2 inches. So you can skip ahead, you can do the math, but I'm going to show some of the math here too. So for the first one, I have I minus 8 AY minus J 16 minus 8 AX. Each of these have unit of pound, inch. Plus K 8 AY plus the second determinant I 2 BY j 16 plus 2bx plus k 8by. All of this should result in 360i. So if you add all of j's together, should be 0. Add all k's together, should be 0. Add all the i's together, and you should get 360. And that's what I'm going to do next. So adding all the i's together, I get minus 8ay plus 2by 360 pound-inch. If I add all the j's together, it should result in 0. Minus 16 8ax minus 16 minus 2bx equals 0. All of these is pound-inches. So this give me 4ax minus bx equals 16. And then my k's, 8ay plus 8by equals 0. So that doesn't help with anything. Could be any number. So that really not a good equation. So let me see. Let me write everything here. This one we already know is 2 pounds. bx, by, and bz we already found it, and that's 2. Just keeping track of what I need to find. Okay. ax, and we had some equations before. We had these 3 equations. ax plus bx is minus 8, ay, by, and so on. So let's use those equations, and hopefully we can find all of these. So ax plus bx equals minus 8 pounds. ay and by, and bz we had it already to be 2 pounds. So let's see what we can do. We have in this equation right here, ax, or let's just start with the first one. In this one, maybe I can replace by. So I have minus 8 minus by plus 2by equal 360 pound-inch. So that should give me by equal 36 pound. Okay. So by 36 pound. Which one I'm going to do next? So next one I'm going to use this equation and this equation together. Try to go somewhere. So ax plus bx is minus 8. And then 4ax minus bx equals 16, and this is pound-inch. So the units are different because the second equations come from moment, which has already inches in them. So a lot of those numbers have inches. So it's okay if the unit don't match. So we can maybe add everything together here. So ax becomes 8/5. So 8/5 is 16/10, so it's 1.6 pounds. All right, what we've got left is 2 more, ay and bx, ay and bx. Well, once you find ax, all you have to do is put it in this equation. So 1.6 pounds plus bx equals minus 8 pounds. So your bx should be, bring this here, minus 1.6, so it's 9.6. So minus 9.6 pound. We have AY. Did we have an equation for that? Yes, we have an equation right here. AY is negative BY, or minus BY, negative BY. So it's minus 36 pounds. 1, 2, 3, 4, 5, 6. I think we solved all of them. So the math is okay. The important part is for this problem to understand is this aspect of it and this aspect of it. So again, goes back to these two major governing equation that we have and how important it is to again apply that equation to every problem. Thank you very much.